Start taking a look at this problem. So really, before I start doing anything with my numbers of 3 and 5, okay, in order for you to be able to draw a conclusion from odds against and get it to probability, this boils down to you got to know what each of these numbers are representing. So what I'm going to draw this back to is our actual definitions. So as I ask some of these questions, I don't want to hear the number 3 or the number 5 yet. We will address that here in a minute. Okay? Odds against is a ratio. It's a fraction, which also can be written like this, in which the first number listed is what? Number of unfavorable outcomes. And the second number listed with odds against is the number of favorable outcomes. Okay, does that make sense to begin with? So, now let's go back to this 3 to 5. Here's what it's telling us. 3 times you're not going to get what you want, but 5 times you will get what you want, right? So I'm going to lose this game 3 times, but I'm going to win this game 5 times. Now, again, we're not going to pull numbers down here yet. How do we find probability? The numerator in probability is always what? The numerator. Number of favorable outcomes. So here's what I'm going to point out right now. My answer needs the number of favorable outcomes, which is already shown in my odds against problem, isn't it? So these two things are in common. The denominator of this one will become the numerator of that one. So right off the bat, I know this is going to have to be a 5. Because literally they are talking about the exact same thing. Number of favorable, number of favorable. Now, what's the denominator in my probability? Number of possible. Now, this is what's not given. This is not one of the numbers on there, because some people are like, well, I've got to put a 5 on the top, let's just put a 3 on the bottom. Except, what would 5 over 3 be? That would be odds in favor. And how do I know 5 over 3 can't be my answer to this question? No, hold on here. Raise your hand, please. How do I know, if I'm asking you for probability, that 5 over 3 cannot be my answer? Because you can't get anything more than what? No. More than 1. When you're doing probability, remember, probability is a number between 0 and 1. That's how we define probability, right? We even have a little chart at the bottom of the page. I can't have an answer to this problem that's bigger than 1. And 5 over 3 is definitely bigger than 1. So, how do we find the number possible? Well, think about it like this. If you lose the game 3 times, but you win the game 5 times, how many total times did you play the game? 8 times. There's your total. This is going to be 5 over 8. Your number of possible outcomes is the number of favorable plus the number of unfavorable. Does everybody see that connection there? If I'm going to play a game 10 times and I won 3 times, how many did I lose? 7. Because 3 plus 7 has to equal my total. So if I won the game 5 times and I lost the game 3 times, I played the game 8 times. That's how you're going to be able to find your total. Okay? So when we first did it, I think it was on last Thursday, we did probability. And then on Tuesday, we did odds. And I told you that by Friday, which is tomorrow, we need to be able to put these all together, because you're going to see these all on one big assessment. They're connected to one another. Here's what I would tell you. I should give you one of those three things: probability, odds in favor, or odds against. If I give you any one of those three, you should be able to find the other two. Okay? But again, one of the things that I want you thinking about as well along the way is what's reasonable. Yes, there was a time with odds against that we just flipped it, but then you got to realize that's telling you odds in favor, which is not what that question's asking. So I'm going to tell you, like, this unit, there's a lot of different ways we're going to do things. There's a lot of vocabulary that you're going to need to know. Okay? You've got to know the difference between probability, odds in favor, and odds against as we go through all of this. Okay? All right. Let's go ahead and grab our notes out. Like I said, I was thinking about that earlier today. We hadn't tied this all together yet, so that was my hope. I'm glad to see that some of you were able to do it without any lead-in from us. We kind of started to draw those connections, but that's my hope, is that we can do that on our own. All right. So yesterday we focused on a tree diagram and the multiplication principle. And I'm going to be honest, the tree diagram is a great visual representation. It is not going to be an effective strategy for us to use a ton of times. Okay, but I do like it. It's a good way to see it. I know they're used in other scenarios and things like that, and so it's nice to kind of get familiar with that. But here's the big thing I want us to remember. What does the multiplication principle says I multiply things together? My question is, and raise your hand again, what does the answer to that represent? What do I use the multiplication principle to find? Okay, the number of possible outcomes. I want you to remember that. It's the number of possible outcomes that's a way something can happen. Okay? Which is huge when it comes to probability. Because as we just reviewed probability, the denominator in probability requires you to know the possible number of outcomes. Okay? Now, today, we're going to talk about the addition principle. The addition principle is not going to tell you how many different ways something can happen overall. It's not going to tell you possible outcomes. It is going to help you relate to your favorable outcomes. Why is that important? Because I need favorable in order to find probability. Right? I need favorable and total. Yesterday we focused on how to find the total. Today we're going to be talking about strategies that we can use to help find favorable. Okay? So we're going to go right to our definition and then get into our examples with this today. Again, this one's a little bit lengthier. Sorry, I didn't give you enough room, but we'll try to squeeze this in there. So, if two events have no outcomes in common, okay, I'm going to pause there, because this is kind of a big deal. What do we mean by no outcomes in common? Okay, here's my example. Think about rolling a die. We're going to roll it twice. And here's my question. The probability that I roll an even, then a number greater than 4. Two different rolls. Think about the first one, probability that I roll an even, probability that I roll a number greater than 4. Do these have any outcomes in common? And the answer is yes. Because what numbers are even? 2, 4, and 6. What numbers on that die are greater than 4? Do they have any common outcomes? Yes. Right here. Those two numbers have a common outcome. So if I wanted to know the probability that I rolled an even and then a number greater than 4, I take that into consideration. Okay? Here's one that doesn't. The probability of a number greater than 4 and a number less than 2. What are my numbers greater than 4? 5 and 6. What's the numbers less than 2? 1. Do those have any common outcomes? Okay. So I want to make sure we understand what that is. Because if they have common outcomes, we have a whole other way to find it. But for right now, if two events have no outcomes in common, we're talking about this scenario right here. Okay? And the first event can occur in m ways, with the second event occurring in n ways. Okay, so the first event can occur in 3 ways, the second event can occur in 2 ways, or whatever. Okay? Then, either of the events can occur in m plus n ways. We're going to add those together. Okay, and again, I'm going to give you an example of this once you're done jotting it down. Example of when I can do this and when I can't do this. Okay, I'm going to go back to a single die. Rolling this once. How many outcomes are there? Okay, I want to know the probability that I get an even number or a number greater than 4. Okay? Some people would say, well, that's 1, 2, 3, 4, 5 ideas, so you have a 5 out of 6 chance of one of those 2 things happening. That's wrong. Why? Because those have a common outcome, don't they? So how many ways are there for me to roll an even or a number greater than 4? There's actually only 4 ways. I could roll a 2, 4, 6, or a 5. Some people might say, well, why not count 6? You already counted the 6, didn't you? So the addition principle doesn't work there. But what if I said, what's the probability that I roll a number greater than 4 or less than 2? Well, how many numbers are greater than 4? 2. How many numbers are less than 2? 1. 2 plus 1 is 3. That would be 3 out of 6. Why does this one work? Because there's no overlap. There's no common outcomes. Well, in the first one, that's what we'll have to talk about. The first one, the easiest way to do it, as long as your sample space is small enough, the first one would be count up all of these, and then count up all of these that you didn't count over here. See what I mean? 1, 2, 3, 4, don't count that one because I counted it over here. So that would be 4 out of 6. Whereas this would be 3 out of 6. Okay? So, we'll talk about the overlapping ones later. Okay, we talk about that probability at another point in time. That's part of our second standard. Okay? But right now, this is how we're using the addition principle. But I wanted to give this as an example because otherwise, if I don't do that, and some of you might think that's confusing, if I didn't give that as an example, I don't know if this makes any sense. I want you to see 2 events that do have a common outcome and 2 events that don't. The addition principle works here. The addition principle doesn't work here. Okay? Alright, so let's get to our examples. Example 3A. You're playing a trivia board game that involves rolling 2 die. One red, one blue. Or sorry, one red, one white. And it doesn't matter what color they are. Like, we do this just so some people have a visual reference here. You use the sum of the numbers rolled to determine the next position of your game piece on the trivia board. For one of your turns, you want the sum of the numbers to either be a 4 or a 6 to move to a desirable location. In how many ways can you roll a 4 or a 6? Now, first question is, would these have any common overlaps? Rolling a 4 or rolling a 6? No, they don't, because they're completely different, aren't they? One of them I roll a 4 and the other one I roll a 6. I can't do them both at the same time. Okay? So this is simply asking us to figure out the number of ways that this can happen. We'll move to probability here in a minute. So here's what you're going to do. And I'm going to tell you, there's not really a quick, easy way to do this. You're going to have to actually think about all the possible ways for this to happen. So, let's start with our 4. In what ways on a die can I roll with 4? Now, again, we're going to do this because sometimes people, it's easier for them to think red and white. I really don't care. We'll list the red one first and the white one second, but it really doesn't matter. Okay? So if I have my red die here, and I have my white die here, okay? Somebody tell me what's one way that I could roll the red die and the white die and end up with 4.
I wonder what that would be because apart from 2 is also 3 plus 1.
Okay, so I could roll, I'm going to start with the 1 on the red, which means I have to roll a 3 on the white, okay? I would say doing this in order is going to help you so you're not missing some. Okay? Well, the next option, of course, would be on the red one is I could roll a 2, which tells me that on the white one I'd have to roll a 2. Or the other option would be on the first die that I roll a 3, and on the second one I roll a 1. Now, this is where the colors help, because some people will be like, but Mr. Tompkins, you already listed 1 and 3. Yeah, but I've got a red one and a white one. So technically this 1 and 3 would be different than this 3 and 1. Does that make sense? Okay. Are there any other ways to roll a 4? No. So we can see right here that there are 3 ways to roll a 4. Now if I don't roll a 4, what's the other thing we want? We want a 6. So we got to think about all the ways that you can roll a 6. And again, we'll start with our red, go to our white, and again, I'm going to do it systematically. So the lowest number that I can roll on a red die and still get a 6 would be a 1. But if I roll a 1 there, then that requires me to roll a 5 on the white. Okay, my next one, of course, I can roll a 2, and that tells me I can roll a 4 on the white. Or I can roll a 3 on the red, which would tell me then I'm going to roll a 3 on the white. Or I can roll a 4 on the red and a 1 on the white. Can I do the 6 on the red? No, because I can't roll a 0 on the white. Oh, sorry, thank you. Oh, so I can do another one, because my next one would be 5 and 1. Okay, so how many different ways can we roll 6s? Total of 5 ways. So there are 5 ways to roll a 6. So now this is where I can use the addition principle. We said specifically that if these are no common outcomes, and they don't, that if there are m ways for the first event, and there are n ways for the second event, that I can simply add those two together, and that tells me that I'm going to have a total of 8 ways to roll a 4 or a 6. is this important? Because this will help you with probability. Okay? Finding the total number of ways that something can come out successful is going to allow you to figure out your probability. So here's my question. Alright? Say I'm playing this game. What is the probability? Let's take this to the next level. What's the probability that I get what I want? Well, we already know the number of favorable outcomes. What don't we know? The possible. How could we figure out the number possible? What's that? Multiply what? Multiply 6 by 6. Why? Because of the multiplication principle. How many outcomes are there on the first dot? 6. How many on the second one? How many total? There you go. So do you see how you're using the multiplication principle to find the total, and you're using the addition principle to find out the number of successes? If I wanted to know our probability, it would simply be, so the probability of a 4 or a 6 would be 8 out of 36, which of course I'd have to reduce, but, and again, some of you are still puzzled on how we got that. You're rolling one die that's got 6 options, rolling a second die that's got 6 options. That's a total of 36 possibilities. Okay, I don't want to have to draw the whole big board up here yet, but like that's one way that you could do it. Okay? So, again, make sure you read the question and you know what it's asking for. This one didn't ask you a probability question, it just said in how many ways can this happen? Okay? So are there questions on this? And again, I don't have any other way to do this. Like, this is going to have to be some way systematically that you can kind of list out. Here's what I want to have happen, and how many ways can I do that? Okay. Alright, then we got another page. And now this page, we've actually got probabilities. You don't get what? If they have the same outcomes. So, no. What's this outcome? These have to give me 4. Any of these outcomes have to give me 4. So none of those are in common. What do those two numbers have to give me? None of those have to give me 4, so none of those are in common. These have to give me 4, none of those have to 4, so none of those are in common. That's what I mean by that. Alright, so example 3B. What is the probability that if you roll their 2 die, your sum is going to be less than 6? Okay? Probability says we need to know all of our favorables divided by total. Let's start with our total. This is what we practiced yesterday. Total number of outcomes. Okay, how many die are we rolling? 2. So just like our opening problem during third period, I'm going to draw 2 blanks. In each of those blanks, we're going to write how many possibilities we have. So for the first die, how many possibilities? 6 for our second one. So how many total outcomes do we have? 36. Again, I'm going to go back to last Wednesday. It's been a long time ago, but I had all 36 probability or possibilities up here. All the different ways that we could roll numbers. Okay? Now, this needs to be the denominator of my probability question because it's total number of outcomes. What do I still need to know to find probability? The number of successes. Okay? So what would be a success here? If I roll a what? Any number less than 6. So let's start with this. What's the smallest number you can roll? Sorry, hold on there. The sum's less than 6. What's the smallest sum you can roll? A 2. Because the smallest you can get is a 1 and a 1, isn't it? Okay. So let's talk about this. I could get a sum of 2. I could get a sum of 3. I could get a sum of 4. Or I could get a sum of 5. We don't include 6 because 6 isn't less than 6, right? So, how could you roll a 2? A 1 and a 1? Are there any other possibilities there? No. Okay, how could I roll a 3? Let's start systematically. On the first one, let's roll a 1, and then a 2. What's another way? A 2 and then a 1. Because those had to give me, that's the only ways I can get 3s, right? Okay, how could I roll 4s? 1 and 3, 2 and 2, 3 and 1. How could I roll 5s? 1 and 4, 2 and 3, 3 and 2, 4 and 1. So these are all the way I can roll 2s, all the way I can roll 3s, 4s, and 5s. Are any common outcomes? No. So, how many, let's do this, number of favorable outcomes. This is where we're using our addition principle. 1 plus 2 plus 3 plus 4, which is 10. We got our pieces, now you just got to put it together. How do you find the probability again? On the top goes number of favorable, and on the bottom goes total. You already got all the pieces there. So the probability of a sum less than 6 is what? 10 over 36. Of course, what are we going to have to do with that fraction? Reduce it. Divide by 2 is 5 over 18. Alright, so here's what I want you to do. I want you to start example 3C here. I'm going to give you about a 2-minute head start. I now have 3 things. I either want to roll a 5, an 8, or a 10. Yep, I want their sum to either be a 5, an 8, or a 10. Because last I checked, they can't roll an 8 or a 10. That's to be their sum. So go ahead and start coming up with that. I don't want you to just, this is what I'm copying. Think about what it's asking you, how you're going to find it, and go from there. careful here, as I'm walking around, I'm seeing people with like 1 and 9 advocating 10. Last I checked, we don't have a 9 on the die, do we? So, all right, I'm going to go ahead and get going over this one. So, 5 I already did because 5 we did above, right? 1 and 4, 2 and 3, 3 and 2, 4 and 1. Okay? How can I possibly roll a 6 or an 8? I can't begin with a 1 because if I roll a 1 on the first die, I can't roll a 7 on the second. So, my first combo is 2 and 6, 3 and 5, 4 and 4, 5 and 3, 6 and 2. 1, 2, 3, 4, 5 choices. Or 5 ways to roll an 8. How can you roll a 10? Well, I can't roll a 1, or a 2, or a 3. Okay? I'm going to start with a 4 and 6, 5 and 5, 6 and 4. There's only 3 ways to roll a 10. So if I want to know the probability that I'm going to roll a 5, 8, or 10, we now need to find the number of favorable outcomes using our addition principle. 4 plus 5 plus 3 is 12. Everybody see how we got 12? Now, what do we know about our total? It's still 36 for the same reason it was above. You had 6 outcomes for the first one, 6 outcomes for the second. That's a total of 36 outcomes. So our probability of a 5, 8, or 10 should be 12 out of 36. Got to reduce that. Largest number that goes into both is 12. That leaves you with 1 third. You're trying to roll 2 die and get a 5, 8, or a 10. You have a 1 in 3 chance of that actually happening. Questions? Megan? Rolling 2 die, right?
Yeah.
How many outcomes do you have for the first one? When you roll a die, how many outcomes are there? 6. Second one, use the multiplication principle to find your total. That's going to be 36 possible outcomes. So again, that's one of the things I'm trying to emphasize is multiplication principle is going to always tell you your total. That's great. That's what you need for probability. The addition principle is what you're going to use to help find your number of successful outcomes. Okay? All right, your homework for tonight is page 330. Numbers 10 through 15 and 19.